Assalamu alaikum. I am Sharmin Akhtar, Associate Professor, Department of Computer Science and Engineering, Atish Dipankar University of Science and Technology. So, thank you for giving me this opportunity to present my paper in this conference. So, the International Conference on Recent Progresses in Science, Engineering and Technology, ICRPSET. So my presentation topic is cost-effective smart helmet for human safety and road accident detection using IoT. And the authors are me, Sharmin Akhtar, MD Abu Yusuf, KM Rafiqul Alam, MD Shohidullah, MD Monirul Islam, and last one, the Ziauddin. For the Faculty of Engineering, University of Rajshahi, and the today's my presentation topics is described by the following parts. Now, my presentation contents are introduction, objective and motivation, proposed solution, specifications of devices, conclusion, references, result, and discussion. So, introduction. In this introduction, I want to share that is a smart helmet is a type of prototype which is used by the rider, which makes bike driving safer than before. And nowadays, road accidents occur very frequently in our daily lives because motorcyclists are not always wearing helmets. So to avoid road accidents, motorcyclists have to wear helmets and the rider can save their life up to some instant. In this paper, our contribution is we have proposed a smart helmet system which is based on Arduino and IoT devices. We have used the 4 specialized sensors, that is ultrasonic sensor, vibration sensor, GPS module, MQ3 alcohol sensor, Wi-Fi module, IR sensor, and relay module. And the design of the smart helmet is to detect whether the user wears a helmet or not with the help of an IR sensor. Apart from this, the smart system can detect whether the user is an alcoholic or not. If the user is alcoholic, the ignition of the bike gets off. Only the ignition gets on while the users wear a helmet and do not drink alcohol. It will benefit riders and medical practitioners when an accident occurs with immediate treatment. This will bring more safety to bike riding and save many lives as well. So our objective, the key objective of this paper is to introduce a smart helmet system, to improve the safety of riders, that it can detect the user is an alcoholic or not, to provide visual outputs such as graphs, different sensors activities for better understanding, and it will benefit riders and medical practitioners also to avoid the bike accident. So in the next slide, our motivation. How can we motivate it? The road accidents become a huge concern in our everyday life, and the number of road fatalities has risen dramatically in recent years. In 2022, a renowned newspaper named Prothom Alo published an article where the Bangladesh University of Engineering and Technology, that is BUET, that says that against every 10,000 motorcycles in Bangladesh, 28.4 persons are dying in accidents each year. So most accidents are due to drinking and riding. The most deaths are due not to wearing helmets. So one of the most important items for cyclists is a helmet. And the proposed solution or the methodology we have proposed, that is, we have used 4 sensors, IR sensor, alcohol sensor, vibration sensor, ultrasonic sensor, and GPS module. So we have used the microcontroller, that is Arduino Uno R3, and get the power supply. In the serial monitor, we get the ignition, that is on or off. When the user is drunken, the ignition is off. Our or the user not wear a helmet, then the ignition is off also. So in the next part, how we can introduce the proposed system is the workflow. How can we implemented the project? That is, at first we start the step, then initialize all the ports, all the sensors, and wait for the signal from IR for detecting the helmet on or not. If the helmet is on, then ignition is signal valid, and otherwise it is locked. Or otherwise, the wait for the signal from alcohol sensor, then the driver is drunken or not. Then if it is drunken, we get the ignition is locked. Otherwise, the ignition is yes. And in the other sensor, that is accident occurrence from SW1815P vibration sensor, and otherwise the ultrasonic sensor is HCSR04. If it is yes, then accident happened, or otherwise no. And the location tracking by using GPS module and lifetime data showing in serial monitor, and we stop the process. Then the following steps we have discussed in the previous slide, and here is outlook. So at step 1, we give power supply to the system and initialize all the parts of the Arduino Uno R3 microcontroller. In the step 2, we wait for the signal from IR sensor. We'll detect the helmet is on or not, and simultaneously the signal from alcohol sensor to check the driver is drunken or not. If the helmet is not on, the driver is drunk, then the ignition lock remains off. Similarly, if the helmet is on and the driver is not drunk, the system will check both signals are valid and the ignition is on. If the system senses a certain level of vibration and obstacle around certain distances, the system detects an accident. If no accident has happened, the system continues its normal operation. If an accident has occurred, the system uses a GPS module to track the location of the rider. After tracking the GPS location of the rider, it will be sent to the emergency contact or hospital to get medical help as soon as possible. And after that, we end the process. So we have used the different types of devices, that is IR sensor, alcohol sensor, vibration sensor, ultrasonic sensor, GPS module, and the relay. And here is the specification of these devices. We can take a look. And the device's workflow, that is IR sensor, can detect the presence of infrared radiation, which can be used to detect objects or avoid objects. An alcoholic sensor is designed to detect alcohol in the air, and the ultrasonic sensor uses high frequency to sound waves to measure the distance of the sensor. And a GPS model is a device that receives signals from multiple satellites to determine its geographic location. A relay is an electrical switch that can be used to on or off a device. The specification of all the devices is drawn to the next table. And the result, in this result part, we see that the initial step and in the final setup of the system. Then the result we get, that is the IR sensor when it is less than 10 centimeter, and in the alcoholic sensor that detects the drunk people in ppm factor, that is if it is greater than or equal to 50 ppm, then the ignition status is on. Otherwise, the ignition status is off. And we see that in the results section also. In others table, we get the vibration sensor, which is greater than or equal to 50 ppm, and the ultrasonic sensor, which is less than or equal 10 centimeter. In that case, we get the false notification when it is 200, which is less than 250, and 20 centimeter, which is greater than 10 centimeter. Then we get the false accident status. So in our summarizing, we see that the vibration and ultrasonic sensor across the system, it comprises data from vibration sensor, which ranges from 180 to 400, as well as an ultrasonic sensor which detects distances between 5 to 20 centimeters. For instance, the first entry reports a vibration level of 340, an item detected at 5 centimeters by the ultrasonic sensor, and a true accident status. In contrast, the second entry displays a lower vibration level of 200, an item identified at a distance of 20 centimeters, and it is a false accident status. This data gives useful insights into the monitored environment. So our cost analysis part, we get the following sensors, the following components, and the quantity, and their price is so nearable at our cost, and 2,810 BDT, which is very cost effective. So in the next section, we see that the result part, the smart helmets are evaluated in essentially 4 different scenarios. It has been noted that the bike will not start when the rider is intoxicated and not wearing a helmet. And in the alcoholic sensor, will identify alcohol and turn off the bike ignitions off. Okay. In the next section, IR sensor detects a positive signal when the user wears the helmet, where the ultrasonic sensor detects a negative reading when the user is intoxicated. These elements aid in identifying bike riders and detecting bike accidents. Bike accidents will be identified by combining an ultrasonic and vibration sensor. And a GPS module will be used to track the rider's whereabouts. So our key findings is the alcoholic sensor will identify alcohol and turn off the bike ignitions, whether it is on or off. And the ultrasonic sensor detects a positive signal when the users wear a helmet. And drunk driving is also a serious topic, and because of it possesses a greater hazard to bike riders than automobile drivers. The ignition mechanism prevents the rider from starting the bike if they breach any of the security regularization. So our conclusion is that wearing a helmet when riding a motorbike is essential, since it can protect the rider's head from serious harm in the event. So this is where the IR sensor will come into play. It will guarantee that the riders wear the helmet before starting the bike. And drunk driving is also a serious topic, which is also detected by alcoholic sensor. So the ignition mechanism prevents the rider from starting the bike if they breach any of the security regularizations. So in this part, we have used the following references to design this project. And in the future work, we will establish, or we will try to implement for the practical in general people to their safety riders. And thank you all.